So if you can hear me, then please let me know. Oh, sorry about that. Oh, yeah. So let me call it once again. Sorry about that. So 이재혁 씨, 고하늘 씨, 심준호 씨, 이승빈 씨, 이윤지 씨, 이정태 씨. 네, 이재혁 씨, 이정태 씨, 고하늘 씨, 이승빈 씨. 오케이. 네, 이정태 씨. 심준우 씨. 네. 오케이. 이충하 씨, 정상하 씨, 장수범 씨, 정민서 씨, 홍주표 씨. 네, 이충하 씨. 네, 홍주표 씨. 네, 나머지 학생들은 안 오셨어요? Okay, so let's go to the third page. 김민선 씨, 김유신 씨, 배민열 씨, 배서령 씨, 서하연 씨. 네, 김유신 씨, 김민선 씨, 배민열 씨, 서하연 씨, 배서령 씨. Okay, let's go to the last page. 이경배 씨, 조대현 씨, 최승규 씨, 믹스터 빅터 쿠자, 김성수 씨, and we have one more student. I guess that his first name is Nadan. So if you are here, please let me know. 네, 김성수 씨, 최승규 씨. Okay, good morning. Okay, then let me check your attendance once again as a final call. 이윤지 씨, 정상아 씨, 장수범 씨, 정민서 씨, 그리고 이경배 씨, 조대현 씨, 미스터 쿠자. So, are you there? Then please let me know. 네, 정상아 씨. 오케이. 땡큐. 조대현 씨. 조대현 씨. 네. 알겠습니다. Okay, so from now on, I will check the late attendance. So let me get started. Oh. Okay, so I'm quite sorry about the delayed starting of our lecture today. So I have some technical problem for mapping our pencil to our sketchbook. So I think that the screen is swapped between my second screen and the third screen. So that's the reason why it took a long time. Okay, so before starting the lecture 3, so I want to ask you whether you were quite comfortable to solve or address the homework number 2. So how was your homework number 2? Do you have any question on the homework number 2? So if you have, then I can try to answer your questions. So if you have any questions, please leave some question in the message window. Okay, so I wait for a while and okay, no question from students. Okay, then I will regard that everybody has well solved that homework problem. Okay, then if you have any question, then you can ask me anytime. So even if you have some question not quite related with that one, that discussion topic, then you can ask me question. Okay, then before starting our today's lecture, let me just announce that no lecture day on this Wednesday. Okay, so in this Wednesday, March 9th, this is our presidential election day. So we have no lecture at all. So please do not come to hear the lecture this Wednesday. Okay. Yeah, I think that everybody understand this one. So our next session will be, March, of course, 14th. Next Monday will be our next lecture, lecture 4. And of course, today we will have homework number 3, and each due is also just before starting our lecture 4. So AM 8 o'clock will be the due for homework number 3. I will shortly after upload our homework number 3. Okay. So do you have any question about no lecture day on Wednesday and our homework number 3 or homework number 2 or whatever? So whatever you have questions, so please let me know. You are always welcome to give a question to me. Okay, then let's get started. So in the previous lecture, we have thought about how can we solve the circuit system. So that was not that difficult. So let me just summarize our previous discussion. So let's say that we have a N terminal circuit element. Okay, then it will have, of course, since this is N terminal, so we will have N different terminals. Yes. So total number of this terminal is of course N. So we start from 1, 2, 3, 4, and there are many other, and this is the final one, nth terminal. Yes, you can think that is general case. And for each terminal, we can define two terminal quantities like I and V. Of course, I is for the terminal current and V is for the terminal voltage. So depending on the node index, usually we use subscript to describe them. So for example, I sub 1, V sub 1, or I sub n and V sub n. So since our each terminal contribute to unknown variables, we have to introduce two equations to solve this system. So what was our strategy? So for voltage, instead of introducing other complicated equation, we just introduce a circuit node, and when our terminal is connected to that circuit node, then we can simply say that, oh, our terminal voltage equal to just node voltage. Yes, so let's say that the voltage of this node as Vn, then that is all for our terminal voltage. Then next question is, how about terminal current? In the case of terminal current, of course, we can ask ourselves, what is the relation for our terminal current? And you know that this relation is really element specific. For example, let's consider one simple, really simplest example, like a two-terminal resistor. So in a case of a two-terminal resistor, then we can say that I1 equal to, for example, V1 minus V2. So voltage difference divided by certain constant called as the resistance. So it is the equation for a resistor. Happen to be, let's say that instead of a resistor, consider a voltage source. So you have already solved that problem in our previous lecture. However, in this case, if we say voltage source and then V2 minus V1 is given as certain magnitude of our voltage source. Yes. Also, we can find the other ones like a current source. That was the second problem of our previous lecture too. In this case, we can say that our terminal current is given as a certain magnitude of voltage. Okay, this is the defining equation for our current source. Okay, up to now we have discussed about resistor, voltage source, and current source. We have two more simple circuit elements, two terminal elements of our interest. So I will just write it down here. So another one is a capacitor. So in a case of a capacitor, we can say that so terminal current is given by a constant called capacitance multiplied by time derivative of voltage difference. So this is another one for capacitor. Also, we can find a dual element to a capacitor, and that is called as an inductor. How about the inductor equation? So in the case of inductor, we can say that the voltage difference is given by time derivative of our terminal current. It can be an equation for inductor. Okay, so I have introduced RLC, resistor, inductor, capacitor, and voltage source and current source. So you can easily understand, although they are quite different to others, however, they can be all share same structure. If you have a certain two-terminal device, then you have just a template for solving the circuit system, and only difference between different circuit element type is just one single equation. If you adopt the Ohm's law, then that will be called as a resistor, and if you just set your voltage magnitude, then that will be called as a voltage source. So that is the difference. Okay, this is the review of our previous lecture. Up to now, do you have any questions about my review on previous lecture? So if you have a question, please let me know anytime. So I will try to answer your question as much as possible. And of course, I have explained about how can we set the second equation for our terminal current. But you know that that is not the end of the story. So we just postpone the determination of circuit node. So previously, when we talk about the terminal current, we say that, oh, I have no idea. My voltage is just equal to node voltage. So if you wanted to the terminal voltage, then please try to calculate the circuit node voltage. Then let's go to the circuit node. Then ask it to how can we understand or analyze your voltage? How large is it? Is it 1 volt, 2 volt, or 3 volt, 4 volt? That is simply obtained by applying Kirchhoff's current law, KCL, to this node. So sum of branch current, written as here certain arrows, sum of branch current should vanish. So by solving this KCL at each node, together with the equation for our each circuit elements, then that will give you the complete set of equations and you can easily solve it. That was the homework number 1 and homework number 2. So you can feel that although the list is long, for example, 10 unknown variables, however, that was really easy to solve with computer programming. Okay, so I think that we are almost close to the end of our lecture review, homework number 2. So if you have a question, then please let me know. If you don't, then let me just start today's lecture. Okay, no question. Okay, then asked by a student in a previous lecture, lecture 2, then main goal of our lecture in this semester is first to introduce the relation which is specific for certain circuit elements. So basically in this course we will discuss about 2 or 3 circuit elements, newly introduced one. So I think that R, L, C and voltage source and current source are known to you. So I will assume that you know it quite well, and they are all linear component. And in this lecture, in this entire semester, we will try to introduce 2 or 3 different nonlinear circuit elements. The first one will be called as diode, and second one will be called as Mosfet, and the third one will be bipolar junction transistor or BJT. So I'm certain that we can treat both of diode and MOSFET completely in this lecture, and I'm not quite sure whether we can have some time to discuss about BJT. But anyway, our goal is to introduce some new element, new circuit elements which is not RLC or voltage source or current source. So that will be the main purpose of our lecture in this semester. Then let's just think about this one. For example, we first consider the circuit element called diode. Then diode, how many terminals are there? It is 2 terminals. Oh, it's not that large number. So number 2, we are quite familiar with 2 terminal devices or circuit elements. In this case, of course, it will have 2 different terminals. One is, instead of just labeling like 1 and 2, it has its own name. So we typically call it as one terminal as cathode and one terminal as anode. So then obviously we can define the, how can I say, the current at cathode terminal and terminal current at anode terminal. That is quite obvious. And also we can define the voltage at cathode voltage and anode voltage. So you can easily understand here, important thing is not the exact value of each terminal voltage, but we have to care about the voltage difference between 2 terminal voltages. Okay, that will be of our interest. And you can find that also there still is a relation between 2 terminal currents. This simply means that cathode current and anode current, when they are summed up, then we have to have a number 0. So simply speaking, once we know the anode current, then our cathode current can be immediately calculated by just multiplying -1 to the anode current. So now the remaining task will be just to give you the relation between anode current and voltage difference between anode minus V cathode. Okay, that will be the first task to define or describe our new circuit element called a diode. If we can provide this relation, then that will be sufficient for us to define a new circuit element called a diode. Okay, so do you have any question about my preliminary discussion on diode? So our next topic will be the introduction of a new relation between I anode and voltage difference. Okay. So if you have a question, then anytime, please interrupt me. I'll be happy to answer your question. Okay, so if you don't have a question, then let me just go to another example. For example, we can think about another circuit element called Mosfet. So in this case, how many terminals are there? In this case, in principle, Mosfet has 4 terminals, but sometimes we can treat it as 3 terminals. Okay, so what is the difference? You will learn what is the difference between 3-terminal description and 4-terminal description of the Mosfet later. But let's consider this 3-terminal description. Then, of course, it will have 3 different terminals, and we can label it as terminal 1 and terminal 2 and terminal 3. But this is not a preferred way. So instead of just using 1, 2, 3, we will call it as a source, gate, and drain. We will use these 3 different, sound quite a strange name, but anyway, we will use these strange names for our 3 terminals. Then obviously we can define terminal current for each terminal. So I source, I gate, I drain are available, and also Vs, Vg, Vd corresponding to source voltage, gate voltage, drain voltage. Yes, we can define them. Then natural question is, even in this case, what is the relation we have to provide, or what are the equations we have to provide? Once again, the sum of source current and gate current and drain current should be 0, just like our 2-terminal device. We have still the entire sum of our terminal current should vanish. So from this one, we can say, okay, source current can be immediately obtained once we have gate current and drain current. So although we have to provide in principle 3 different equations, but by applying current conservation, so we can neglect one of them. So now our goal becomes describe the terminal gate terminal current and drain terminal current as a function of voltage. So our eventual goal will be gate current as a function of, for example, gate voltage referenced by source voltage and drain voltage referenced by source voltage. And also, if we can provide drain current as a function of Vg minus Vs and Vd minus Vs, then that will be all for us to define the characteristics of our new circuit elements called Mosfet. So our lecture will progress exactly in the same way I introduced in this lecture. First, we will introduce the characteristics of a diode, and using this diode we will try to solve some systems. After that we will move to Mosfet and first describe the relation of gate terminal current and drain terminal current to fully specify the Mosfet device. After that, we will discuss about the operation of some Mosfet devices or some Mosfet circuits. That will be our lecture progress. Of course, if time allows, then I will introduce a similar device called BJT, but I'm not quite sure about whether we will have sufficient time to discuss about BJT circuit element. Okay, so that is a more detailed overview on our lecture progress in entire semester. And if you have any question about my explanation, then please let me know, so then I can repeat my discussion again and again. Any question? Okay. Since no question is arrived from our students, then I will just go into the next topic, like introduction of diode. Okay, but anyway, anytime when you have a question, then please let me know. I can answer your question. Okay. Okay, so now let's think about our circuit element called diode. So here we have a name called diode, and diode simply means that this is two terminal element, because you know this die, the prefix die is corresponding to number 2, and odd means the way. So way means that the terminal. So the way is the way to conduct current. So this is corresponding to two terminal. So simply speaking, this diode is another name for two-terminal device. Of course, a resistor is a two-terminal device, and inductor or capacitor are two-terminal circuit elements. So saying that diode as this, so use this diode term diode to specify this element is not that much specific. But anyway, this is there is a historical reason why we call it as a diode. So just accept it as a historical reason and say that this is a diode, then you can easily raise that question. If there is a diode, then is there any other device or circuit which has three terminal whose name is ending with odd? If we have three terminal, then odd is way for terminal and three. For example, triode. Is there any component or any circuit element called triode? Yes, there is a device called triode. Usually that is not called in these days, but actually our Mosfet has certain operational part where it is called as in triode mode. Okay, so simply speaking, the name itself does not give you much information about its operation. Just looking at its name, we can realize that, oh, there are two terminals there. So that is all for our name, not that specific. Then let's just directly dive into the relation. So from our previous discussion, now you understand our ultimate goal for describing this circuit element is to find out the current relation between the relation between our terminal current and voltage difference. That will be the ultimate goal for describing this circuit. But you know that you have already many different relations. For example, why don't you think about our previous elements like voltage source? Our voltage difference is given by a number. Yes. And how about the current source? Current source, in that case, the current is given by a number. And how about your Ohm's law? Ohm's law, just to specify I R times V, yes, equal to 0. Of course, 0, this is a number. Oh, so think about this one. If we consider certain system which is depending on here I and V, then actually if we just consider any kind of linear combination between current something plus voltage something equal to certain number, then you can find this kind of relations. You can generate many different relations out of this simple linear combination of terminal current and terminal voltage difference. So then what is the difference between these one, so voltage source, current source and resistor, and this one? The difference is all of these combination is this one is all a linear combination of our current and voltage. So simply speaking, the circuit elements which will be called as a diode does not have the linear relation. Their IV relation, their IV relation will not be a linear function. There will be a non-linear relation between terminal current and terminal voltage difference. Please remember this important difference between this RLC component and our new component or circuit element called as a diode. What is the fundamental difference between this and that? Here we have linear relation between voltage and current, and here we will have nonlinear relation between current and voltage. Okay, I think that is really an important factor we have to keep in mind. So I just ask you whether you understand the difference. So please, all students, please leave your message that you understand the difference between RLC and diode. Diode has a nonlinear relation between terminal current and voltage. That is important. So if you understand this point, please say that I understand this one, or if you have any question, then please let me know. I will try to answer your question. Okay? So please everybody leave your message. Okay, good. Mr. Kim, okay. Good, thank you. Good. Okay, so great to all of you understand. Okay. If you have any question, it is really good to ask me a question. Okay. Asking question is a really good practice for your further improvement. So I really wanted to encourage you to make a question or ask a question. Okay. Then now let's go to this. What is this new component called diode? So now we understand it will be a non-linear circuit element. So let's think about the comparison between our diode and resistor. Resistor is a linear circuit component. So let's just think about this one. Here we have a diode. Well, although diode has its own circuit symbol, I will just postpone its introduction. So let's say that there is a certain black box which is called a diode, and it has a cathode terminal and anode terminal. And in order to make a comparison, we wanted to introduce a well-known circuit element called a resistor. Say that this is minus terminal, and say that this is a positive terminal. Whatever, 1, 2, or 0, 1, plus minus, NP, any name is just okay, but I will just use plus minus sign. This is resistor, and say that here I have applied 0.0 volt to the cathode, and here I applied 0.0 volt to minus terminal, and I applied, for example, 0.7 volt to anode and 0.7 volt to anode. Yes, you can easily understand. Only the difference is I just changed the circuit element between 0.0 volt and 0.7 volt. Yes, you have voltage difference across these 2 points, and first put on the diode, after that remove it, and a resistor will come. So just to observe the difference. So then what will happen? Let's just consider first our resistor. So in this case, there will be certain current and the direction of your current will looks like this, obviously, because positive terminal is highly biased and negative terminal is lowly biased. So it is really obvious that you will have this downward direction for your current conduction. In this case, you will say that, okay, for positive terminal, what is the sign or polarity of your terminal current? Obviously, you will have positive current, and here this current flows through in this way, and yes, in this way. In this case, your minus terminal current will be just negative 1. Why we have negative 1 for negative terminal? It is because for this field, we always treat the incoming terminal as a positive one. So for minus terminal, we have outgoing flux, outgoing terminal current. So we will call it as negative sign. Of course, you know that the absolute value of I positive and absolute value of I negative should be the same. So, any question? I think that is too obvious to you because this is just a resistor. But let's move to our diode. Then now we go to the diode in left side and now see what happens. Okay, since we have applied also positive bias, relatively positive bias to the anode current, then we can have certain anode current. Okay, anode current, and yes, that current will flow, and since this circuit element is just two terminal, there is no way for our current is splitted. There is only one way, so the incoming current flowing through the anode should escape through the cathode. So you can say that also cathode current will have this polarity direction, and it is regarded as negative sign, and this one is positive sign. And you know that absolute value of I anode and absolute value of I cathode are the same, so they are equal to each other. Any questions? So it is exactly same as before the resistor case. Okay, now although depending on the resistance or the size of a diode, the actual value of I anode or I plus can be different, but here what we have to consider is the sign. So anode and cathode. Since anode is highly biased, so anode has a positive sign, and since cathode is lowly biased, we have a negative sign. So if you have a question, please give me the question. Then maybe you can easily understand this is not the final discussion of our lecture because this is too obvious. The important thing can happen, we change the polarity or swap the polarity. So let's use the blue letters from now on. So now, instead of 0.7 volt to the positive terminal, I just swap the voltage difference. It is easily achievable because here we have 0 volt and here we have 0.7 volt, and in between there was a resistor, and just put it out and just change it or swap its two terminals and put it again. Then you will have exactly the same voltage difference. However, the polarity is now swapped. So our now negative terminal has been highly biased and our positive terminal has lowly biased. Then what will happen to this system? So what is your opinion? Of course, in this case, since we have applied higher bias to negative sign, negative terminal, then we will have incoming flux from this terminal. Okay, then obviously since this is a two-terminal device, there is no way out, and we will have just same amount of current flowing through this way. Oh, in this case we have to say I minus terminal is positive and I positive terminal is now negative. That is too obvious. But my point is, now when you compare the value of I plus when it is biased as a positive 7 volt and I minus when our negative terminal is biased with positive 7 volt. What is the difference between these two quantities? What is your opinion? Could you please leave your answer? So since this is too easy, so I think that all of you can easily answer my question. So we have a resistor R and we have applied 0 and 0.7. Then there will be a current. However, instead of 0 and 0.7, we just apply 0.0 and 0. So we just swap the voltage configuration and see what happens to our terminal current. Then what is your opinion on these two terminals? So my question is I plus when positive terminal is 0.7 volt and I minus when minus terminal is 0.7 volt. What is their relation? Could you please answer me? So that everybody can answer this question. Okay, so please go ahead. Okay. Okay. Good. Oh, really good. Okay. Good. Thank you. And so for other students, please leave your answer. Yes. as you, all of you correctly answered, they have the same magnitude. And you know that even they have the same sign. So both of them are quite close to, both of them are positively numbered. Okay, so you know that is the main reason why I ask you this question. This is a resistor. You know it quite well. Then let me just visit our new component called a diode. Then now I apply. Now I apply 0.7 volt to our cathode terminal, and here I apply 0.0 volt to our anode terminal, exactly same like the resistor case. Then obviously once again, since this cathode is highly biased and anode is lowly biased, therefore we will have a certain current and we will have a certain current. Even in this case, we will have cathode current, which is now positively numbered, and anode current, which is negatively numbered. And of course, this blue eye cathode and this blue eye anode has the same magnitude and only the opposite sign, because in order to have the current conservation. Okay, so do you have any question or do you have any objection about my explanation up to now? For example, in this case, I cathode can be differed from I anode, not only their sign, but also their magnitude can be different. If you can ask me, of course you can ask me that question, but point is, always their magnitude are the same and they have the opposite direction, opposite sign, so they have completely cancelled out. So what? What is the difference? Why I'm spending too many minutes on this quite obvious one? Then now the point is, how about the relation between this one and this one? Now I'm asking you the real question which I wanted to ask you. So let me just delete this resistor example in order to secure sufficient spaces for our sketchbook. But you know that you have a complete understanding on the resistor case. So now I'm happy to move to our diode example. So let's go. My question is, how about this? We can have anode current, positive anode current, and it is obtained when our anode is positive 7 volt. And now we can have another positive current, the cathode current, when cathode voltage is now become 0.7 volt. And now asking you the relation between these two cases. Previously, in a resistor case, I positive when positive terminal was biased with 0.7 volt and negative terminal current when negative terminal is biased to positive 7 volt, they were the same. simply speaking, just swapping the sign gives you just swapping the terminal current sign. So terminal voltage is just their sign is changed when we change the voltage sign. But when we go to a circuit element called a diode, then the answer is in this case yes, they are different. This is the main message what I wanted to deliver in today's lecture. Okay, so let's say if we have same diode and this is cathode and this is anode, and this is cathode and this is anode, and 0.0 volt, 0.7 volt, and 0.7 volt, 0.0 volt. They are placed in a different situation. So can you understand the difference between the diode and the resistor? For resistor, if we consider resistor, then there will be no change in terminal current. The magnitude of terminal current will be the same. It is just given by 0.7 volt divided by resistance. So V over R, that will be the current. However, if this is a diode, then it has its own preference on the polarity. For example, it loves to have the anode voltage is higher than cathode voltage. Then it becomes really conductive. However, it don't like to have a case where cathode is highly biased than the anode terminal. So, simply speaking, for diode, this one is preferred way to conduct a current, and this one is non-preferred way to conduct current. So there will be no current conduction. Okay, so can you understand this difference? So not only the voltage difference, in both cases we have a voltage difference of 0.7 volt. However, not only the 0.7 volt, but also is it the positive 0.7 volt or negative 0.7 volt. The polarity is also important for the diodes. That makes a big difference between the diode and a resistor. Okay, so I wanted to stress this real important difference to you. So could you please, all of the students, please repeat that you have understood this difference between diode and resistor. So when you apply positive value, relatively positive voltage to anode node, then it conducts. The diode conducts. However, if you apply higher voltage to cathode, and it does not conduct at all. That is completely different from the resistor. Okay, this is a really easy fact. However, that is also quite important. So could you all of our students please leave the message that you have understood this one. Okay, thank you. Thank you for your participation. Okay, good. Great. Okay. But if you have any question on my explanation, please let me know. Then now we have just 4 minutes. Then I will just, yes, thank you. Then I will just important graphs for our discussion. Okay. So typically people love to draw such a diagram in order to identify or characterize our circuit elements. It is a two-dimensional graph, and its x-axis or horizontal axis is V, voltage, and its vertical axis or y-axis is I. So yes, let's think about this one. If we apply 0.7 volt to our, how can I say, resistor, then what will be the current? Of course, we will have a certain current, and its value will be given by I equal to 0.7 volt divided by the resistance R. You can understand it. But when we apply the same voltage with the opposite side, minus 0.7 volt, then what will be the terminal current for the same terminal? Then obviously we will have also the terminal current is given by minus 0.7 volt divided by resistance R. So we will have exactly a mirror symmetry between or symmetry against the origin. Here we have origin and our point, this point and that point, just symmetry, point symmetry across this origin. That was the resistance. Then how about our diode? In the case of our diode, as I told you before, when the anode voltage is higher than the cathode voltage, then we can have a certain conduction. Okay, so we don't have any information about the exact y coordinate. What is it? I. But anyhow, it is far from 0. However, important point is that if this is a resistor, then we will have the same point when we have minus 0.7 volt voltage excitation. However, this is not the case for our diode. In our diode, this minus 0.7 volt is not a prepared configuration for current conduction, so it essentially conducts zero current. So that is the difference. You know that when we just connect them all, then this IV characteristics of a resistor just looks like a, sorry about that, so sorry about my ugly drawing. Our IV characteristics of our resistor just looks like a straight line. However, if we go to the non-linear circuit element called diode, and it just looks like this way. Yes, this is really highly non-linear curve. Okay, so time is up, so we have to stop now, and we will continue our discussion on next Monday. We have no lecture on this Wednesday because Wednesday we have a presidential election. Okay, then let me just call the late attendance once again. 이윤지 씨, 장수범 씨, 정민서 씨, 이경배 씨, 그리고 미스터 쿠자. So if you are here, please let me know. And all other students, you are allowed to leave the live streaming. Okay, see you next Monday. Bye. Then I will distribute the homework number 3. So shortly after. Bye. 아무도 안 계신가요? 이윤지 씨, 장수범 씨, 정민서 씨, 이경배 씨, and Mr. Kujak. So if you are here, then please leave your message. Okay, nobody here. Okay, I will just close the streaming. Bye.